I'll run through the main components that make up this compressor. The first one, obviously, is the compressor itself. It's a second-hand fridge compressor that I bought from eBay. The compressor is a Danfoss make, and you can still obtain from the internet data sheets for all of Danfoss's products. So once I bought this compressor, that was the first thing I bought, I was able to download the data sheets and have a real understanding of what it is I'd actually purchased. The second thing I bought was the pressure vessel, which came from Germany, again via eBay. The vessel itself has a capacity of 7 litres, and it will withstand a pressure. It's tested to withstand a working pressure of 11 bar, which is equivalent of about 160 psi. Now, I'll be running this, and I have been running it at 100 psi or less, so that is a fairly good safety margin that we have built into that. The controller came from China. This section here, it comes with the gauges, with the pressure switch, and you have to provide the connections here for connecting the air hoses on, the air lines on. The receiver has 4 entry points, 1 on the top, 2 on the sides, and 1 directly underneath. As you can see, I have the controller mounted on the top. I have the one on this side blanked off. The one underneath is fitted with one of these blow down valves. It has a piece in the centre. I don't know if I can do this one-handed. That centre piece you can slacken off. It has an O-ring seal, and you can use that to blow off any water that gathers in the bottom or condensation that gathers in the bottom of the vessel. And on this side I have the non-return valve. So we'll just run through how the compressor actually works and explain the function of these items. And if you buy a compressor, it will come with 3 short pieces of pipe that will have the ends bent over and sealed just for postage. To determine what the 3 pipes are, you can connect it up and just run it. Connect it, wire it up and run it. And what you'll find is that one of the pipes has a suction. That's this one here. The other one has a discharge pressure, which is this one here. And the other one does nothing, which is this one here, which is where the oil gets filled into the casing when the compressor is made. Now this one will look as if it's had a permanent silver soldered seal, where the pipe has been flattened and silver soldered to seal it. And the other 2 will look as if they've been cut off to disconnect the compressor from the fridge or the freezer that it was attached to. So the way the air flows through this device, this piece here is a small air filter. You should be able to get the top off of this. There we are. And you can see it's a paper type air filter that's in here. Just twists back on. So it goes in through the air filter, down this hose, through the compressor, The high pressure comes out this hose underneath here and into this non-return valve, through that and into the air vessel. Also attached to the non-return valve is a small pipe which comes up to the controller, and the purpose of that is to remove the high pressure from the section of pipework here on the discharge side of the pump set in the compressor, so that when the pump in the compressor starts up, it's not starting against the maximum pressure that's been held in the bottle here, it's starting against atmospheric pressure. And once we have the air under pressure in the bottle, we have the option of tapping off from either of these 2 points here. The one on the left hand side is controlled by this valve. This controls the pressure coming through this line. The one on the right hand side, always the air always comes out of there at whatever pressure is in the bottle. You can't change that here. So this dial here only controls the pressure from this side, and this side here is always at the pressure in the bottle. And that gauge on the top of there tells you the pressure in the bottle, and this one here tells you the pressure in the line coming up from this side. On the end of here we have a safety valve which you can pull with your hand. It's very stiff, and that just blows off if the vessel does get over pressurised. It will blow the pressure off before the bottle explodes. This controller contains the on-off switch. Pull it up to switch it on, push it down to switch it off. And if you push it down, or it switches off because there's a spring mechanism in here that works off the pressure, it's connected into the pressure side underneath here. And if it either gets up to pressure or you press this button down, you'll see there's a blow of air comes out of it, and that is the pressure releasing from the pipe going down to the discharge side of the pump set. Inside this casing is a motor and a compressor, and the compressor discharge comes out via this pipe here, and all of the pressure in there empties when you press the stop button. This cable here goes to a normal 240 volt plug. You need to make sure that it's a single phase compressor unit that you buy, not a 3-phase, and that the voltage suits your local voltage. And the cable on the other side of the switch goes down to the compressor. I'll turn the unit round and you'll see it a bit better then. Right, so here we have the other side. You can see we have the high pressure coming out here. This is the inlet from the air filter. There's the inlet to the air filter. So the air comes in here, through the compressor inside, out through here, through the non-return valve, into the vessel. When the power shuts off, the non-return valve closes, and there's a valve inside the controller that releases any pressure from this line here, so that when the compressor starts up again, it starts up against atmospheric pressure, just zero pressure, and not the full pressure that's been held in the vessel here. That's obviously to put less demand on the motor when it first starts up. The takeoff points, standard takeoff points for Euro type fittings. Just push in there, then you, as this pops forward, you push it back and it pops back out again. There's also a pressure release point in here. As you can see, you can slide that backwards and forwards, a very tight fit. So when it's that way, it keeps the pressure in, but if you pull it forward you can actually release the pressure in there, just to allow you to drop the pressure down if you want to, for any reason. There's a lock on here that you can use if you have the pressure set on this side for a paint gun or for just blowing down, and you don't want it to be adjusted. You can set that up and lock it so that it's fixed at whatever pressure you require. All of these components are mounted on a frame made just from square section steel. I think this is 25, the main beams here, and this is 20. And this is just some box section steel that I had in my shed. I did a bit of fabrication. It was my first attempt at using an old MIG welder that I'd been given. And as you can see, some of the welds are a bit lumpier and a bit beefier than they need to be. However, it's holding together well. It won't fall apart, that's for sure. And a lick of paint covers a multitude of sins, so it actually looks not too bad when it's painted. On the top here, the handle for lifting it, I had no real way of knowing where the centre of balance was going to be, so I made the handle so that it could rotate. It's a tube inside a piece of steel rod, so I can, when I lift it, it can swing and it finds its own centre of balance, and it makes it a lot easier to carry. The ends of the tube, to tidy them up, are fitted with plastic caps, these square hammer-in plastic caps. So once they were cut to size, squared the ends off and hammered in these caps. And underneath here you'll see rubber feet. So there are 4 rubber feet that the whole unit sits on. In addition to on the compressor, let's see if I can get you, there's a better picture there. Hang on a minute. There you see on the compressor, underneath the mounting plate of the compressor, there is a rubber vibration absorbing mounting, and there's one of these on each corner. So we have 4 vibration mountings for the compressor and 4 rubber feet where it sits on the floor of the shed. Now I'll plug the unit in, switch it on and let you hear it running. Now this camera is about 2 feet away from the unit at the moment. Now, as you can hear, it is very quiet indeed when it's running. But before it gets up to pressure, which it will struggle to do because I have a small air leak at the moment coming out of here, before it gets up there I'll switch it off and tell you about the 2 modifications I'm about to make. One is to fix this air leak. I made this pipe out of stainless steel. Quite awkward to work with, quite stiff. So I'm going to replace that with something a bit more flexible. You can see it's not gone in square into this connection here. If you can just see into there, it's gone in at a bit of an angle, and that's what's causing the leak. It's only just developed that. It was fine initially, so I could probably get it back again, but I want to just replace it and do it a bit better. And that goes in underneath here on another awkward to get to fitting, but I'll come up with something. What I think I'll do is just replace it with a bit of rubber hose like this stuff here. And the other thing I want to do is replace the blowdown valve on the underside of this vessel. because it's almost impossible to get your hand underneath here and switch off when it's on the floor of the shed. Is extremely awkward. So what I'll do is fit a valve, possibly this one, I'll fit it onto the frame somewhere, and again use a bit of flexi pipe round underneath. I'll make an adapter for underneath the vessel, and connect it up that way, and then I can just open this valve up and blow the vessel down anytime I want to. To mount the vessel on the frame, you'll see it's sitting on a piece of plastic about 1 inch thick. I turned that on the lathe to allow for the curvature of the vessel so that it sat into it. Made contact right out to the edges, and there's a hole bored through the centre to allow the blow-off valve to be fitted. The vessel is sitting on that plastic vessel, that plastic ring, but it's clamped on with 2 bits of stainless steel bandit. These have just been coated in heat shrink plastic, and I've fixed these onto brackets. So I shaped the bandit into a curve to fit around these what are essentially nuts here, and found that clamped it very well against the bracket here. So these 2 ends have been clamped like that. I'll just get this camera. So these 2 ends of the bandit have been clamped like that. It just goes around the back of the steel bar, and there's a bolt goes through the centre of it, and I've drilled a hole through the bandit, and that bolt goes through the hole in the bandit. On the other end of the bandit, I found in my scrap box 2 ends of an old stainless steel turnbuckle, probably used for yacht hand railing or something. One's a left hand thread, one's a right hand thread, but they had nuts on, so I was able to use them both. And you'll see the clevis pin going through here. I've just folded the bandit back on itself, drilled it, put the clevis pin through, held in place with this ring, and then I made a half round nut on the back of here so that it aligned with the back of this bracket when I tightened the conventional nut up on it. So that allows it to come in at an angle, and just tightened it up on there, and it's held extremely firmly. It is not going anywhere in a hurry. I have 2 of these straps, as you can see, holding the bottle onto the frame. The air vessel, if I can focus a bit on this, you can see I've fitted some spacers in here. There's another bit of right angled bracket here, and I've fixed on with these screws just some white plastic spacers, so the bottle sits up against 4 of these spacers, one here and 2 on the other side, which means it's clamped into these and pulled into these with these bandit clamps. The plastic ring on the bottom, I've put 2 bits of angle iron onto it so that it slides up and down inside the square sections of the frame. So if I undid this, that whole bottle could slide out this way, and that was the easiest way of tightening. The only things I have to tighten up then are these, because the bottle sits square against these plastic sections, just bits of plastic, round plastic bar, and this floats up and down, and it's these 2 bolts here that hold the whole of this bottle in place. So we had the air in and the high pressure air out. I've opened up the third pipe that came out of the compressor. As you can possibly see there, I've stamped it with oil just to remind me what it is. And you can see in there, there's a pipe that's fitted on there with Loctite. When the compressor comes, it will come with the oil in it that they use when it's connected to a fridge or a freezer. It's a very thin oil. I believe that it's designed to allow some oil to leak past into the pipework of the refrigerant system to act as an anti-corrosion. So I was told by our fridge engineer anyway. If you get some oil through the pipework of the refrigeration system, it prevents the system corroding. That oil is too thin, because what you don't want is oil getting through into this vessel and interfering with your spray gun, or if you're doing a bit of paint spraying with an airbrush, then you don't want any oil getting through to that. So I've emptied the thin oil out and used just conventional compressor oil, SAE 30 grade compressor oil that I got from a local superstore. And that seems to be working okay, because there's not too much oil coming through and there are no strange noises coming out the compressor. Right, so I'll go ahead and make these modifications. I need to make a couple of parts up. I'll make these modifications and then I'll bring you back in once I have the parts ready. Alright, so here we have the first modification finished. This is a new pipe from the non-return valve on the air receiver up to the controller. It used to be made from a piece of stainless steel, but this was an absolute nightmare to get installed because of the lack of flexibility. It's quite a stiff, thick-walled pipe. So I've replaced it with a bit of rubber pipe and some fittings on either end, just right-angled fittings to accommodate this rubber pipe. You may have noticed the connectors that I've used are the crimp type connectors. I bought a kit specifically for doing this compressor. This is it here. You have a whole range of sizes. The ones I've been using for 6mm pipe sizes, I don't know if you can see them, but they are written on the side. This one's 13 to 15, I'm struggling to read it myself there, 13 to 15. These are the pliers that you crimp the ends in with. And they work very well. And you push the hose over this type of fitting, slide one of these connectors down, crimp the two sides, and that is going nowhere. So that's the first improvement done. I shouldn't have any more leaks out of that system, out of that section. These are the small blow off sections. So that's it starting. You can see the pressure beginning to build up. vibration with it sitting on the bench. It comes up fairly quickly, and certainly quick enough for anything I want to do in the shed here. Just touching the red when it blew off there. Right, so that's us back on the bench again. We have our adapter made to go from 1/2 inch BSP down to 1/8 of an inch BSP. We have a right angle bend which will fit into this 6mm hose, and we have a 6mm connection that will go into this ball valve. The ball valve I'm going to mount somewhere in about here and have the hose going underneath onto this connection onto the bottom of the air receiver. So that's what I'm going to work on next. This hose, by the way, I'll just show you the writing on it. There it is there. It's SAE J30 R9 fuel injection hose. Obviously the material that it's made from is suitable to resist fuels, petrol, diesel, etc. But it also has a maximum working pressure somewhere in the region of 100 psi, which is what this system runs at, and a burst pressure somewhere around 900 psi, which is way in excess of anything that this system could achieve. So safe enough using that system for these applications, or this tube for these applications. The other tube I'm using, silver line, and it's just a length of compressed air hose. You buy it very cheaply. You can buy about a fair length. I can't remember exactly what it was, maybe about 10 metres on eBay for only a few quid, and it's designed obviously it comes with fittings on the end for connecting to a compressor and then to a compressed air tool, and you just cut these off and use whatever length you need, and this type of crimp connector, and it will do fine. It means you've got loads of spare hose should you ever need to replace any of them in the future. But so far I've been using this set here for over a year now, and the hoses have been perfect. I've never had a leak other than from one of these small connections here, which I've just replaced. So I'll go on now and I'll fit these bits up and I'll make a bracket up to mount this ball valve, and come back to you when I've done that. Right, so a quick search through one of the scrap bins has come up with a small piece of angle iron which I can mount somewhere on there, and then this valve can sit through there and I can fix it onto the angle iron using the other end of this valve, which has a 1/4 inch BSP. I'll just make up a 1/4 inch BSP nut, or I might make up something that maybe out of brass that has a bit of a nozzle on it just to tidy up, because when I open this up there's going to be some water squirts out, and I'll maybe put a wee nozzle on it so I can direct that possibly into a container. So I'll go and have a go at something like that. Right, so we're getting closer to completing this modification. Have the valve now mounted on a bracket on the side of the frame. I found a Euro connector with a female end, a 1/4 inch female end that fitted the end of the valve, so I've used that to clamp the valve in place on this bracket. So that's worked out quite well. I have another fitment here, which is a 1/4 BSB on this end, and it goes into a 6mm rubber hose here. To go into the bottom on the underside of the bottle, I've made this, as I showed you earlier on the lathe. That's now ready to go in. It has an 1/8 inch BSB hole threaded in the base. That will take this bracket, so that will go in there. The hose will come out, curl round about through this way somewhere, and meet up with this connector here. And that will allow me to blow any water off just by opening and closing this valve. And it's a modification that was desperately needed because there's some water that had gathered in the bottom of it. It lets you see just how much comes in there, and all that's doing is corroding the inside of the pressure vessel. So definitely a modification worth doing. Here's what I had fitted previously, but yeah, as I say, you had to put your hand underneath to unscrew that centrepiece to drain any water away. I also modified the one I had fitted. I put a big washer on, and that was to give me a bigger surface area to seal against this boss. But I think in hindsight that may have been a bit of overkill. Well, I hope it is anyway, because what I've done with this one is just use the size of brass hexagon that I had and fit in PTFE tape. If it does leak, then I can do the same as I did with this, take it back out, solder a bigger washer on, and put a different kind of seal on. But for the time being, I'm just going to try it like this. So the next time you see this, this will all be fitted, the hose will be connected, and it's going to take me a day or so because I'm going to paint this bracket before I connect it all back up. So I'm going to dismantle this and paint this bracket now. And just to give you a better look at the bracket before I take it away for paint and take it off, there it is there, the hole in the side for the valve going through, and two holes to take M5 bolts. I've drilled and tapped M5 into the frame. It's quite a thick walled square section tube that I used for this. So it took a thread. I've got two M5 threads side by side, and that's the bracket in place. And obviously all the corners have been taken off so you won't catch yourself or your hands when you go to move this or go near the valve to let any water out. Well, here's the bracket, suitably painted, and a couple of 5mm bolts that I found in the drawer. They'll fit onto here. I'll just fit that up just now. And here we have modification number 2 complete. Valves here. Turn it in the way when it's in line, that's the valve open, and any moisture can blow out along this pipe through this nozzle, and I'll catch it on a cloth or in a cup of some kind at this end, and then the valve gets turned that way obviously to close it off. And that's worked out really well. The hose is quite tidy, doesn't need securing, it's sitting there and attached to a 90-degree bend fixing underneath. Right, I'll see if I can show you the fixing underneath. I'll pull the compressor off the bench a bit and just give you a little look at that. So there's the compressor balancing precariously, and you can see the fitting underneath. You can see the bits of it's actually old drawer runners that I've used, just bits of angle iron fixed onto the plastic so that slides along in the frame, and that just holds the bottle in place, stops it moving from side to side, and the bands up the top here and these screws then take care of the rest of the security. Works very well, it's very solid. It is balanced quite precariously there because it is heavy. One other fixture I had connected to this was this device, and it's a dual purpose device. It catches moisture in this left hand side receptacle and allows you to put oil into the right hand receptacle, and the idea is you take the moisture out there as it gets blown down the line towards your tool or whatever it is you've connected to the other end. But you can also drip feed oil into, if you're using compressed air tools, you can drip feed oil into them as you use them. This compressor though is not, it doesn't have sufficient volume of air to use the high volume compressed air tools. So really all I was using this for was to take moisture out. So the right hand side wasn't getting used at all. I can still use it. I had this on a bracket at the side of the compressor, but I'm not going to fit it back up again. I could still use this if I wanted by just pushing it in here into these auto connectors and leaving it sticking out the side there, and then connect the paint gun into here. And I might look at something along the lines of modifying this to separate it and just fit. I also thought of filling this left hand container now, which is the one that would have the oil in it, up with silica desiccant as a further help towards drying the air, because if you're using this with an air gun for painting, then you don't want to have any water coming through at all. So I might leave that there. That's something I can experiment with and see if it helps any. But that's the compressor more or less finished again now, because I've just decided not to add this. I was going to put this onto a bracket on the frame, but I'm not doing that now. I'm just going to leave it the way it is. The airbrushes that you use for painting, this type of airbrush, this is just a typical example. There's a cover on the end here, and your paint goes either in a bottle like this or in a small cup like this, and these work great from this size of compressor. They work really well. I've got a couple of them now. I use them for just painting small lathe parts, mask them off and spray them up. And it does give you a better finish. You need to thin the paint down, so I've found that I tend to try and buy enamels that use white spirit as a solvent. And the giveaway is, if it says clean your brushes in white spirit, then you know it's got white spirit as a solvent. And I find that just a small drop extra white spirit is enough to make it thin enough to spray through this gun. I try and avoid this. I've got paint with xylene that stinks to high heaven. It can't be doing your lungs any good. So I try and avoid that for this type of spray application. But I'm very much a novice at spray painting, so if anybody knows better, please feel free to add some comments down below. I'd certainly appreciate it. This is the compressor back where it lives, with the flexi hose connected back up. I have just a normal gun on the end. It hangs on the drip tray of my Myford ML7, which is handy then just for picking up to blow away any swarf or clean the tool post or anything I want to do around the lathe. And it's also, because it's coiled, it's long enough to reach any other point in the shed if I want to blow anything else down as well, like my drilling machine or anything at the vise. going to do a bit of an experiment now. I'm going to get a stopwatch and see just how long it takes us to get from 0 up to 100 psi, just to let you see how effective it is. Right, I think you can see that. I have a watch here. I'll try and let you see. There it is. The scale on this thing, I don't know if you can see that the way that the light is, but the scale on there, when it reaches just into the red, it's 120 psi. So I think I'll be running at just about maybe 110 psi, somewhere about there. Right, so stopwatch at 0. I'm going to start the stopwatch and try and do this at the same time. In fact, what I'll do is I'll rig the camera up. Give me just a second. Okay, that's the camera rigged up, so I now have a stopwatch and this hand in use, so I'll start the compressor. And the gauge on the left hand side is the one that's controlled by this knob. The gauge on the right hand side, if you can see that, possibly there, possibly that's a bit better. If you can see that going up, that's the one that's reading the actual pressure, the full pressure that's in. Oh, now that's 40 seconds. That was a zip it. Now up at 90 psi, and that's a minute and 10 seconds. So, no, a minute and 31, maybe a wee bit slow there and pressing the button, so say a minute and a half to fill that air receiver, which is pretty good. It means I now have the compressor clicks itself back in and it will bring it up. And more at the point, it does it very quietly, which in a small shed like this is what you want. You don't want. I have a 2.5 horsepower compressor. I think I bought it from Aldi's out in my garage that I use for some of the compressed air tools. And when it's filling, it is really noisy. It's not something you want to be standing beside. Whereas this, quiet, and it does the job very effectively. So altogether, very pleased with the end result. And just before I finish, I'll show you this working. This is the valve I fitted in. And I'm sure I agree, if there's any dirt or water in there, it's going to come out with a fair old bit of pressure. That's going to be enough to shift anything that's decided in there. I did give it a good blow down earlier, and it shifted some muck from inside the bottom of the bottle. So definitely a good idea to move that valve out to an accessible point.